So to understand suspension transitions, first we need to understand the problem it helps you solve and why it's not a good idea to solve it manually. A lot of these terminologies I borrowed from the article from Ryan Carniato. I'll link that down in the description if you're interested. So the problem is, what do you do when you are waiting on some data? It can be a network request, it can be a file read. What does your UI do? Let's say if I press this tab, what should it happen? So let's look at some possibilities. First thing you can do is you can bail. Bail basically means I don't know what's happening. Let's just show a loading state while we are waiting on the data. So this is the bail approach. This works pretty good. This is the base case. You should always implement a loading state while you are waiting on data. So the second option you have is called tearing. All tearing means is that you will show the loading state if you don't have any data. But if you switch data, let's say I go from Charmander to Squirtle, then it will show Charmander while Squirtle is loading. And you can somehow convey that what the user is showing is the old data. Here I will grayscale it. So this is tearing. You show the old data while the new data is loading. And the thing about this is, let me increase the delay on the request so I can show you this. The great thing about this is that the user can still interact with this. I can still like this, read this, and do all this stuff. You see the like doesn't go to the next thing. The like is still for Bulbasaur. There you go. So your page is still interactive, and that's a good thing. So this is really the main problem that suspension transitions help us solve. This is really hard to do by yourself. I'll get into it why it's really hard, but let's talk about the third one. This is a special case. You can only do this one when you are the one who's creating the new state. So here I'm creating a new Pokemon. Let's say it's Pikachu. I add it. So what I can do is I can show the new state even though my request is not complete, because I am the one who created it. This is called optimistic updates. And the good thing about this is that if your backend is really like up to par, and this is this is better user experience, because most of the time you don't expect the request to fail. So you can just update the UI even though the request is not complete, because you are being optimistic. You are assuming that the request will succeed. And this leads to a faster and better user experience. One thing about this is that you should not let any interactivity like likes happening while the request is not succeeded. Otherwise you would have conflicts. You cannot like something that is not in your database. Example. Let's look at these slides for more context. So let's look at the bail approach. I'll decrease this delay. And let's see what happens. So the current state goes to the loading state, and the future state is being loaded in the background. And then when it is loaded, it goes to the current state. Let me slow it down for you to see. So you see, the current state, Charmander. Then we go to Squirtle. The current state goes to the loading state. It destroys the current state and makes it loading state. The future state is loading. It loads. It goes back to the current state. Let's look at what's the difference when you go to tear. So in tearing, you see, we don't destroy the current state, and the future state is where the loading is happening. When it loads, it comes back, and the current state is updated. The future is interesting one. It's the most different. You fill your forms, you add it, or you maybe delete something. You can also do optimistic updates for deletion. And you replace the current state with the optimistic state immediately. And the future state is loading in the background. You will also hear the word concurrent rendering when working with suspense and transition. All that means is that it is rendering two UIs at the same time, the future state and the current state. That's all it means. Okay, now let's look at some demo code. So this is solidjs, but the code is identical in React for the most part. And Vue has suspense, but I think they only have the fallback option. And last I checked, Svelte doesn't have any kind of suspense mechanics. They only have their await thing, which can only handle one promise at a time. So let's look at solidjs code. So the first thing you need to do is wrap the asynchronous UI in a suspense tag. So here the async part of the UI is the image and the description and the like button. So that's what I wrap in the suspense. You can provide a prop to the suspense tag as the fallback. Here the fallback is the spinner. Here I'm basically saying if we don't have the we only show this when we have the info. And this is how I do the show that the state is old. If the state transition is pending, then I add a class called grayscale. Same with here. I make the text gray. Let's see what happens when it change tabs. So here on click, you can bail, and you would see that the only difference between bailing and tearing is that you wrap the state change in a start transition. Where do you get the start transition function from? Both React and solidjs has two options for this. Either you can use the start transition directly from the core library, or you can use the use transition hook. The reason to use transition hook is when you want a pending state. If you don't want a pending state, just use the start transition directly. Here I need the pending state, so I use the use transition hook. I get the start transition function, and I get the pending state. Then for optimistic updates, what I do is whenever I submit the form, I mutate the current info. So in solidjs, you can mutate an asynchronous state using the mutate function they give you. So I just mutate it as soon as I submit. And then I start a transition to the next tab so that it can actually do its thing and fetch stuff. After the transition is complete, the mutation is automatically removed because the info is replaced with the new state. And the UI is for the most part same because the optimistic state and the new state should be same. That's the whole point. Okay, so now that we've talked about the code and we've understood the concept, let's see why it's not a good idea to do this yourself and how hard it would be. So let's say you wanted to do this yourself. First, you probably would need to create pending state yourself. So that's the first thing. You need to manage your own pending state. And let's say you do this. You do manage your own pending state. But here we only have one async resource. Let's say you had more. Let me just copy this. You add info 2. you add info 3. Then you need to track pending states for all of these. So you would need to do pending 1, pending 2. Then you would need to create a derived value that probably ORs all of these pending states. You see how quickly it gets out of hand, and then you probably need to set pending states here to probably true. Then you can set it to false here. Then same here, you would need to set your pending state here. You see how many points of failure there are. There are so many points of failures when you try to do this manually, and it's really bulky code. If you use suspense and transition, it just handles it for you. And you might be saying that this is not a fair comparison because there are 3 infos here, and in this suspense example, it was only 1. But the thing you need to understand is you wouldn't need to do any of these pending states. The transition pending state would automatically wait for all these 3 to complete if you read these resources in a suspense boundary. You wouldn't need to keep track of any pending states and derive a global pending state from it. Also, in terms of pairing, here you would need to show 2 UIs here, probably one being when the pending state, and you would need to keep track of the old information. So that every time you create your bail, you would need to set the old info to the current info. And yeah, so it gets really hard the more you try to do this manually, and that's why suspense and transition exist, and that's why it's a good idea to not reinvent the wheel in terms of facing consistency. If you have any questions, leave them down in the comment section, or if you want me to deep dive into the code for solidjs or React, leave that down in the comment section too. Thanks for watching.